Good evening, my dear students. In previous lecture, we have done the derivation of discharge for Venturi orifice meter. Now we will do a problem on orifice meter. Here I have written the problem. In the problem, orifice meter diameter is 15 centimeter inserted in a pipe of 30 centimeter diameter. That means we have given DO solution. DO, that is the orifice diameter, is 15 centimeter, and so A naught is pi by 4 15 whole square. It is comes 176.7 centimeter square. Now the diameter of the pipe is given as D1 is 30 centimeter. D1 is 30 centimeter, and the area A1 is pi by 4 30 by whole square is equal to 706.85 centimeter square. S oil is given 0.9, and we know that differential head H star minus H2 star is H1 star minus H2 star is del X rho m by rho minus 1, where del is the x is the manometric deflection, rho m is the manometric fluid density, rho is the density of fluid flowing through the pipe, minus 1. If we put the value of all this, because here the manometric fluid is mercury, if we put all these values, then we get H is equal to 705.5 centimeter of oil. Now CD is given 0.64. So the formula becomes very simple. That is, the discharge formula is CD A1 A2. We have derived this for the Venturi meter. Root under A1 square minus A2 square 2GH. We know the A1 A2. We know the H. We have find out the manometric head, piezometric head difference. We have calculated it. We know that H1 star is equal to P1 by rho g plus Z1, and H2 star is equal to P2 by rho g plus Z2. It is called piezometric head, and the difference between them gives the pressure head or manometric head. Here del X is the manometric deflection shown in the differential manometer. So by putting all these values, we can get discharge is equal to 137.414.25 centimeter cube per second, and in liters it is 137.414 liter per second. So it is a very simple problem. You have given the area of the orifice plate, you have given the area of the pipe, you have given the density of the oil flowing through the pipe, and you have given the manometric fluid, that is mercury, and you know the formula of H. H is the manometric differential head. So by putting this, we can get H is equal to itna, and putting the discharge formula, we get the discharge. This type of problems come in the exam. These are very simple problem, so you don't need to worry, and you solve from the RK Bansal. In case of any problem, you can comment on this video. Now second thing, now the other topics comes, that is the Pitot tube. Pitot tube, it is the third application of Venturi meter. So before that, we will study about the static, dynamic and stagnation pressure. So many application we use, many application of Bernoulli's equation are those where the datum head is equal. That means P1 by rho g plus V1 square by 2g, and Z is equal. So P2 by rho g plus V2 square by 2g. If it is equal to P naught, then P naught is called the sum of static pressure and dynamic pressure. This is called static pressure, and this is called dynamic pressure. So P1 by rho g is called a static pressure, and V1 square by 2g. Similarly, P2 by rho g is called static pressure, and V2 square by 2g is dynamic pressure. So we can write P square P by rho g plus V square by 2g is P naught, and this P naught is stagnation pressure. Stagnation pressure. And stagnation pressure is defined as the pressure when the velocity becomes zero. This velocity becomes zero. When the velocity becomes zero, then this pressure will maximum, and that in that case P1 by P by rho g is equal to P naught, and that P naught is equal to stagnation pressure. Means P by rho g plus 0 is equal to P naught. Then this pressure is maximum, and this pressure is called stagnation, unequal to P naught, and P naught is called stagnation pressure. And the point where the velocity becomes 0 is called stagnation point. So stagnation pressure is nothing. It is the pressure where the velocity of the flowing fluid becomes 0. So it will raise the pressure, and that maximum pressure is called stagnation pressure. Now we will come to Pitot tube. Here there is an arrangement of Pitot tube. This is the arrangement of Pitot tube. It is a device for measuring the velocity of flow at a point in pipe or a channel. It is based on the velocity. It is based on the principle that the velocity of a flow at any point becomes 0. Then the pressure is increased to the conversion of static pressure, the conversion of kinetic energy into pressure energy. In this simplest form, Pitot tube consists of a glass tube bent at 90-degree angle. The liquid rises when the velocity is 0. Then the liquid rises up in the this tube due to conversion of kinetic energy into pressure energy. The velocity is determined by the measuring the rise in the liquid in the tube. Consider 2 points at the same level in such a way the point 2 is just as the inlet of the Pitot tube, and point 1 is away from the Pitot tube. Here P1 is the pressure at here, B1 is the velocity at this point 1, and P2 is the pressure at this point 2. Similarly, V2 is the pressure at velocity at point 2. Velocity at point 2. H is equal to, we come like that. H is equal to depth of tube in the liquid, and H is equal to rise of liquid, So applying Bernoulli's equation at 1 and 2, Bernoulli's equation at 1 and 2, we get P1 by rho g plus V1 square by 2g plus Z1 बराबर P2 by rho g plus V2 square by 2g plus Z2. P1 by rho g is the pressure head at 1. P1 by rho g is equal to H, pressure head at 1. P2 by rho g is equal to pressure head at 2, and it is equal to H plus H. So substituting these values into the Bernoulli's equation. And what is the Bernoulli's equation? We have seen P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. As we can see that from the figure that datum height is same, so Z1 and Z2 is cancelled, and the velocity at the velocity at the the velocity here we can see that the velocity is v1 and here velocity is v2. So in this figure, when velocity is v1 and pressure is p1, that is equal to p2 by rho g plus v2 square by 2g. So here the application of stagnation pressure is used. Here velocity is v1, but when the velocity goes to this enters into the tube, velocity becomes 0. Then the head rises in this tube. When the velocity is v1 here, then the height is h1. So pressure p1 is h1h. Static pressure is h1. But when it goes, steam flow goes to this point, velocity becomes v2 becomes 0 and total pressure becomes h plus h. So that's why I have write down the instead of p1 for p1 by rho g, it is h1 and v1 square by 2g. v2 is 0, v2 is 0 and v2 is 0. For p2 by rho g, I have write down h plus h, p2 by h plus h. So you can understand that here velocity is v1 and static dynamic pressure is v1 square by 2g, static pressure is p1 and p1 is equal to height in the column, where when the water or liquid fluid is here, then height is h1. When it comes here, velocity becomes 0 and the pressure becomes the stagnation pressure. Then that pressure rises because the kinetic or velocity becomes 0 and this is h plus h. So I have hope you will understand it, and that from this equation we can h and h is cancelled. H and h is cancelled, so v1 is 2g root 2gh, and that velocity is theoretical velocity. But in actual, we know that we have get the theoretical velocity. But in actual, we know that we have not considered the losses in this flow. So actually, there are some losses due to the friction. So a concept arises, a term arises, that is the coefficient of viscosity CV, and CV. Actual velocity is CV root 2gh, CV root 2gh, where V theoretical is always greater than V actual, because theoretical velocity, this is theoretical velocity, V theoretical barabar root 2gh. Theoretical velocity is always more than actual velocity, because in actual velocity friction losses is considered, and CV actual velocity becomes CV root 2gh, where CV is always less than 1. So finally we can write at V actual barabar CV root 2gh. So this is the formula for the velocity, so from this we can find out the velocity from the Pitot tube, and after that continuity equation we can get the discharge. So hope you have understand it. Thank you very much. In the next video we will go through the numericals problem. Please like my channel, subscribe it and comment on it. Thank you very much. Stay home and remain safe.